So they didn't
Why are you hearing that?
You're dropping bombs.
For interviews.
This has nothing to do with it.
Don't you already? You're wasting Dexter's time.
Okay, are you guys ready?
Yes.
Okay, so step 3, so initial solution. As I said before, we pick our initial solution, you pick x equals 0. Well, we are assuming that b is greater than or equal to 0.
Yeah.
If that's not the case, we'll talk about what we do later. Right? So next step is optimality test, right? Can you guys see this? What's written here?
So what did you added that little extra bit?
Z equals to, so this is our this is our,
You wrote the max line
So you
downstairs.
added a
this is
Z.
our objective function. Z is equal to 3x1 plus x2 plus 2x3. I just copied that here.
I remember in lecture Eduardo asked why is there a 2 there and then everyone was confused. It's
For
like
2 where?
a Z.
Wait, what? Where? Wait, where?
The Z, because she wrote Z.
Okay. Alright, so,
That's how you know the lecture is bad.
alright, so what is the optimality test?
Okay.
We have to check
If every coefficient in Z is negative.
We're gonna send it to my.
bonus mark.
How do you know these?
Okay, you went to lecture. Alright, so, shh, quiet. Alright, so we check if every coefficient is negative. If every coefficient is negative, we're done. Can someone tell me why?
Already satisfied. No, because you definitely not further. You can't make S like more positive. Like,
Yeah, exactly. If all the coefficients are negative, and if all the coefficients are negative and the x's have to be greater than 0, right? So remember that all the x's have to be greater than 0. If the coefficients are negative, there's no way you can maximize it further. Remember, we're only talking about maximization because we change all linear programs to maximizations, right? So if you see negatives on every coefficient, we're done. If not, we have to choose a pivot. Okay, so this is the tricky stuff.
But when you say negative coefficient, it means z equal to that
Yeah,
coefficient.
this z line, right? So we're keeping track of a few. So this is like our algorithm here. We're keeping track of this z plus our slack variables, right? So what do? We choose a pivot, right? So what we do is we pick a non-negative coefficient. So here I'm going to pick x1, right? Yes.
wait, so when you said like X is equal to 0, like what do you do with that?
So that's our initial solution, right? We have, in this simplex method, we have to initialize our solution. So our initial solution will be that all of the x1, 2, 3, 4, 5, and 6 are all 0. That's our initial solution. It's feasible because b is greater than or equal to 0.
So like you don't actually like sub in the X, like X equals 0 into like any of that.
No. No. That's just our initial solution, right? We're going to modify it to get the final solution. Okay? So if, for example, if all the coefficients were negative, then our final solution is that x is 0. That's what will give us the maximum of this guy, right? Which makes sense because if these guys had negative coefficients, the maximum value would be x is 0, right? That's why. So we choose a pivot. So here, pick the largest non-negative coefficient, and what we'll do is we try to increase it as much as we can by looking at these slack variables. So what do I mean? So remember that x1 is constrained by these guys, right?
Yeah.
So what we're doing is here, in this line, can you guys see the board? So in the first line, x4 is equal to 90. Let me see if that's correct. Oh, that should be 30. My bad.
This changes everything.
This changes the whole game now. My understanding of the question just disappeared.
I don't even know what linear programming is
Okay,
anymore.
so we have to see how much we can increase x1 by. So here, how much can we increase x1 by? Well, we know that x4 has to be greater than 0, right?
Yeah.
So if we increase x1 by 5, it's still greater than 0. If we increase
by 30.
x1 by 30, x4 is 0. If we increase x1 by 31, what happens?
It's negative.
x4 is
guaranteed.
negative. So we stop when x1 becomes 30. What about for this line, x5, 24 minus 2x1?
12.
How much? 12. This last one? 9. So how much can we increase x1 by?
9.
You guys are good. I told you this course is
Wait, what the heck just happened here?
Do you understand?
No.
Okay. Dumbass. Okay, so in this step, what we're trying to do is we're gonna pick the first variable with the largest positive coefficient. So in this case, x1, right?
Yeah.
You get that?
Yeah.
Now, x4, x5, and x6 are these equations, right?
Mm-hmm.
Now, x4 has to be greater than 0, right?
Yeah.
So how much can we increase x1 by such that x4 is greater than 0?
We can guarantee.
And remember that x2 and x3 are 0, right? Because in our initial solution, x2 and x3 are 0. They're all 0 right now. So assuming that they're all 0, we only have to look at 30 minus x1. How much can we increase x1 by to guarantee that x4 is positive?
Like, you mean what can I set x1 to?
Yes, exactly.
The 30.
30, right? If I set it to 31, 30 minus 31 is negative 1. x4 cannot be negative.
Yeah.
Same thing here. How much can I increase x1 by?
12.
12, and here?
8. No, sorry, 9. 9.
9. So how much, what's the most we can increase x1 by?
9.
9, exactly. So that's what this step is. We're going to find the first positive coefficient. We're going to keep increasing it based on the slack variables, right? And then what we do is, so once we figure that out, we're going to solve for x1 here. Right? So we're going to say that x1 is equal to, let's see, I have it here, 9 minus x2 over 4 minus x3 over 2 minus x4 over 4, right? So what happened?
What?
So I took this equation. So we decided that this is how much we can increase x6 by, right?
Yeah.
We're just going to isolate for x1.
Okay.
So move 36
So where's
over.
x6 then?
x6 is
Basically x4.
x4 should be x. Yeah, sorry. Good catch, guys. Good catch. Good catch. Who said that? Is getting the one.
I'm racking them up tonight.
All right. So what do we do next? So now that we solve for x1, what we do is replace x1, or you see x1 here. And this whole thing, you replace it, right? So here,
This is actually like fucking too much work. Holy fuck. Why the fuck you call this simplex? There's nothing simple about it.
so what we do
It's
is
simple plus complex, but simplex.
we sub in x1 here, right? And what you'll end up getting is z equals to 27 plus x2 over 4 plus x3 over 2 minus 3x6 over 4. So that's our new z value, right? So remember, at each step we're keeping track of those z's and our slack variables, right? Same thing for x4. You substitute this x1 into that guy, and you get a new x5 equation, right? So I'll write that down. What is that? So now x1 becomes a new slack variable. So x1 is our new slack variable, is 9 minus x2 over 4 minus x3 over 2 minus x6 over 4.
Question,
Yes.
I forgot. What did you do with the z?
So z, what
Plug
I
in
did
x1.
was I sub in, so remember, we isolated for x1 here,
Yeah.
and then we sub that guy back into this z variable.
Okay.
3x1 plus x2 plus 2x3.
Oh, so we subbed in.
Right, so this is our new z.
Okay.
We just subbed in the old z, which is equal to 3x1 plus x2, and we just rearranged and we got that. So we do this for every single slack variable, and you'll get a bunch of new values, right? I won't write them down
So
on
like
the slides. If you look at the slides.
3 z values and
So you'll end up with x1 because we replace this x6 with x1,
Mhm.
and then we'll still have x4 and x5, but now they're modified because we subbed in x1 with that new guy over there. So
oh, it's still doing the next coefficient. Yeah.
So what happens? So you'll have x1, x4, and x5, right?
Yeah.
Okay, so basically, when you try to solve for one of the slack variables,
Yeah.
you choose the equation that gives you the most constraint on that variable.
Yes.
What if you have two with the same?
Then
Yeah,
just pick
question.
one.
So far, the reason we left x2 and x3 out because they're 0 at this point.
There's 0 at this point. So right now, our new vector, so our initial vector was all zeros.
Yep.
Now that we've done our first iteration, our new vector is x1 is now, what did we say, 9, 0, and then the remaining vectors are still all zeros, right?
Yeah.
So we've set x1 to 9, we've kept all of them at zeros. But now look at the new z. One important thing to note is that now before it was 0, now it's at 27. So basically what we're saying is that by increasing x1 by 9, we've increased our objective function by 27. Right? So we're trying to increase this as much as possible. Right? So in our next step, we do the same thing. We pick the largest non-negative coefficient, and we look down our slack variables, and we repeat the process until we get all negative coefficients. Once we get all negative coefficients, you'll have some, at each step, you update this x vector, when you have all negative coefficients, what happens is that this guy will be your objective value, your final objective value, so the max value, and you'll have an x vector which will be your solution. Alright, so 4 is repeat.
So initially we had z equals to 0.
So z equals to 0 and x equals 0.
Yeah.
Alright, assuming that b is greater than 0.
And when you pick the max coefficient, you choose the positive max value, not absolute max. So if it was -3, 1, +1, and +2,
Yeah,
you would
remember,
choose
we
2.
ignore negatives. We ignore negatives.
Negatives, okay.
Yeah, right?
Think
So-
about it, when she was going through this example, all the numbers of on her slides were wrong. All the numbers. Can you imagine that David was like, I don't get it, what's happening here? And she's like, the numbers are wrong, whatever. Can you imagine? Like, fine.
Alright, you guys get that? So convert to standard form, convert to slack form, do our initial solution, optimality test, so check the coefficients, and then what you do is you choose the pivot, so you choose the variable, variable, and then after that, you update your x vector, you update your z, and then you update your z vector and you repeat. You guys get that?
Yeah, just one more question. So next step, we would choose x3 1/2 as the coefficient for next
Yeah.
step, because that's a max
and then,
value.
And then you look down, and you see that you can't do some shit. And you make it work.
So we have to practice it.
That's how I do my tests.
Watch, you just like rinse and repeat. Like, what the fuck?
Choose a value and hope it's gonna work out.
All right. Well,
Okay, we've got half an hour.
let's take a 5-minute break and we'll move on to the next lecture.
Wait,
Do-
what?